Recovering Ship 40 after weeks at sea will show how much structural and thermal data survives saltwater exposure for the next round of Starship iterations. This is SpaceX Daily, episode 76. The upper stage has spent roughly a month in saltwater after its Indian Ocean splashdown. Engineers would still examine attachment points and residual tile thickness to set lower bound durability numbers before the next design cycle. The semi-submersible heavy lift vessel Forte is tracking toward Christmas Island with an ETA of August 23. Its 177 by 43 meter cargo deck offers ample space to cradle the 52.1 by 9 meter ship and secure its remaining tiles. Crews will need custom cribbing and tie-downs to protect the heat shield remnants during transit. The vessel's deck stiffness and tie-down geometry become part of the overall reuse cost model once port cranes rated for a 100-plus ton cylinder are unavailable. Observers tracking the AI's signal note that the arrival window aligns with the earliest practical opportunity to lift the vehicle off the beach without local heavy lift infrastructure. Remember, we covered Starship flight testing yesterday, and this recovery moves the durability questions forward by supplying real exposure data ahead of repeated tower catch attempts. While the team extracts real-world durability numbers from S-40, another proposal is exploring an entirely different orbit for compute hardware. The proposal treats satellites as disposable compute nodes whose short orbital lifetimes would generate a novel waste stream. The economics mirror asteroid mining in reverse, with launch mass traded against on-orbit processing power. No recovery or deorbit hardware is described in the concept. Each node would add to the long-term orbital junk problem rather than reducing it, unless launch costs fall far enough to make frequent replacement cheaper than ground facilities. The same hardware path that enables Starlink-scale constellations would also set the cadence for replacing failed orbital servers. Worth keeping an eye on. SpaceX's concept for orbital data centers would turn satellites into single-use compute platforms whose short service lives create a new, hard-to-mitigate category of space debris. Without demonstrated deorbit or servicing hardware, each node adds to the long-term orbital junk problem rather than reducing it. The approach only closes economically if launch costs fall far enough to make frequent replacement cheaper than on-ground facilities. Critics note that the mass-to-orbit trade-off resembles asteroid mining run in reverse, yet no recovery architecture is described. Regulators and debris modeling groups would likely demand explicit end-of-life plans before any large-scale deployment. On the launch side, a third-party operator is already using Falcon capacity in a way that could one day carry small orbital processing experiments. Portal has purchased a Falcon 9 to fly its first supernova spacecraft and will sell remaining capacity to secondary payloads. The arrangement adds one more Falcon mission to the manifest without requiring a dedicated SpaceX launch. Rideshare customers gain access to the vehicle's excess volume and mass margin once the primary supernova spacecraft is integrated. The deal demonstrates how third parties can secure entire Falcon 9 flights and monetize unused performance through secondary manifests. No specific payload mass or orbit details for the rideshare slots have been released. Observers tracking the Forte's AI's signal note its arrival window aligns with the earliest practical window to lift Ship 40 off the beach without port cranes. Commenters question how much post-flight tile and stringer data can still be recovered once the vehicle has spent weeks immersed in salt water. The prolonged exposure is expected to attack both ceramic tiles and underlying metallic stringers. Any surviving attachment points would still give engineers a lower bound durability number that ground tests alone cannot supply. On the AI front, SpaceX's orbital data centers would create a new category of e-waste by treating satellites as short-lived compute nodes. The Ars Technica analysis frames the mass-to-orbit trade-off as asteroid mining run in reverse, with no recovery architecture described. Portal Space Systems' decision to sell excess Falcon 9 capacity for its supernova mission illustrates how rideshare economics can extend to non-SpaceX payloads. The arrangement adds one more Falcon flight to the manifest, while allowing secondary customers to share the vehicle's performance margin. This model could indirectly support distributed compute experiments if future rideshares carry small orbital processing test articles. The engineering angle here is that Ship 40's month-long immersion in the Indian Ocean creates a controlled experiment in material degradation that Starship designers can use to bound real-world heat shield and tank performance. Salt water attacks both the ceramic tiles and the underlying metallic stringers. Any surviving attachment points or residual tile thickness after weeks of exposure give a lower bound durability number that ground tests alone cannot supply. If the recovered hardware shows that the current tile-to-structure interface survives this environment with only modest mass loss, the team gains confidence that the same stack can tolerate multiple orbital cycles before refurbishment. Conversely, widespread corrosion or debonding would force an earlier redesign of the attachment scheme or a change in tile composition before the first tower catch attempts. The decision to lift the vehicle onto the Forte rather than attempt an at-sea transfer also reveals a practical limit. Without port cranes rated for a 100-plus ton cylinder, recovery logistics shift from simple barge operations to specialized heavy-lift vessels whose deck stiffness and tie-down geometry become part of the overall reuse cost model. The 177 by 43 meter cargo deck of the Forte provides enough area to cradle the 52.1 by 9 meter ship while leaving margin for custom cribbing that protects remaining tiles during transit. Watching how much of the original tile map and tank pressurization data remains usable after the transit will directly inform whether future ships can be caught, reflown, and caught again within the reuse cadence now targeted for late 2026. Engineers will next compare post-recovery measurements against the single-engine deorbit static fire already performed on an earlier ship. That earlier test demonstrated the engine's ability to perform a precise burn after orbital exposure, yet it left open the question of how much additional structural data survives prolonged saltwater contact. The answers from Ship 40 will set quantitative limits on refurbishment intervals and help decide whether the current heat shield attachment scheme meets the requirements for repeated tower catches. A quick look at the tape shows SPCX moving higher. Before we go, the data recovered from Ship 40 will set the refurbishment intervals to watch before the next tower catch attempts. And that's a wrap on today's SpaceX developments. SPCX is trading at $134, up 0.5%. Share this with a fellow spaceflight fan if you found it useful, and subscribe so you don't miss tomorrow's episode. I'm Patrick in Vancouver. See you next time. Quick tip from the network. Try the Do Positive Pod next. Good news in science and tech, plus one concrete action you can take. Every NARA Network show is free at naranetwork.com. And on the website, every episode's visuals live in our free image gallery at naranetwork.com/gallery. Royalty-free under Creative Commons. Download with attribution. This episode used AI voice synthesis of my voice. Editorial selection and analysis are my own.